Hi guys, this is the Math 7 video for Unit 1 Lesson 2, Corresponding Parts and Scale Factors. If you're viewing this video, that means you've already navigated through Canvas enough to figure out where the lessons are and what lesson it is. So I'm not going to give you the directions on how to access that. However, I do want to make sure that you understand the different ways that you can be taking notes and learning in your online learning experience. The first thing that I want to make note of is that this video is probably playing directly in Canvas about right here. It's not there right now on my screen because I'm making the video, so it's not there yet. When I'm done making the video, I will embed it here so you can see the little video right here. But if you are trying to take notes or see what's going on and you scroll past, you're not going to see that video anymore. So what I suggest, if you're going to work through the Canvas instance and you're not going to have your notes in front of you, pop that video out into its own tab. I'm going to create a separate tab right here, and you can see I can just slide it on over. Of course, it's not going to work quite that way in the video. I am going to slide it over so that one side would show the video and the other side, let's see if I can make this work, has all of the stuff in Canvas. So here would be the video playing, and this is going to be where you're scrolling through in Canvas. So pop that out, okay? That option is going to be something like view on YouTube or something like that, but that way you can watch the video and still see all of the notes here in Canvas. Another option that you have is if you go into Canvas on that home screen, and I went over this in a previous video, then you scroll down to where it has the Unit 1 scale drawings. You can see the class notes. Those are the notes that we take in class. And this is the actual document that we're going to be going through. So Unit 1, Tasks and Practice. When you open that, it takes you to a OneDrive folder where you can see all of the PDFs that I've prepared so far. This is Unit 1, Lesson 2, so this is the one that we would want to open, and it pulls up this PDF which you can print. This is the way that I suggest you do it. If you have access to a printer, I suggest that you print these out and physically take notes on that copy as I go through the video. If you don't have access to a printer and you feel like you can learn just by watching, then that's okay too. I want to now compare a few things after supposing we have printed this off, and also comparing it to what you see in Canvas. In Canvas, here's the lesson, and here's the actual PDF. There we go. What you can see is that they are very similar. It starts by telling you that we're doing a number talk, and you can see the number talk. You can see corresponding parts, but this is where it starts to get a little bit different. Here on the PDF, we have these images, and you don't see the images here on Canvas. However, you do see this option in Canvas, and it says View Applet. When I click on the View Applet, it pulls up those same images. So the directions for students who are learning in person are going to be use tracing paper and use your tools and do this stuff. You don't probably have that same set of tools with the tracing paper and protractors, and so this applet still allows you to complete that activity even though you might not have the same tools for learning in person. So for this video, I am going to be using the applet to show you what to do, but I will also give instructions for using tracing paper for those that need that. Now that we've gotten all of that out of the way, let's begin. Unit 1, Lesson 2, Corresponding Parts and Scale Factor. We start with a number talk, and although right now this particular number talk might seem very unrelated to the rest of the lesson, it's because it really does play a really big role in the whole entire unit. We're going to come back to this and readdress this again and again and again. And what we're being asked to do is it says find each product mentally. If we just focus right here on 1/4 times 32, I want you to think of what process you would use to find that mentally. Pause the video now to give yourself enough time to do that. And now we're back. I'm hoping that you did something like this. We know that 1/4 times 32, we would need to create a fraction so that we can multiply those fractions. So 1/4 times 32 is 1/4 times 32 wholes. And now that we have fractions, we can simply multiply straight across. 1 times 32 is equal to 32, and 4 times 1 is equal to 4. And now that we have multiplied those fractions, we're left with 32 fourths. This also means 32 divided by 4. And I'm hoping that you also know that 32 divided by 4 is equal to 8. Now, it does say mentally calculate, but you can see that I did a lot of writing. It's because I want you to understand that this is the way that we would multiply that and get to that end result, but I want us to be able to skip a couple of steps mentally as we progress into these other problems. So if I have 1/4 times 32, knowing that I'm going to change 32 into 32 wholes, and then knowing that 1 times 32 is still 32 and 4 times 1 is still 4 and nothing changed, I'm hoping that you can very quickly, mentally, go from this place to this place and know that it's 32 divided by 4, which again you can calculate mentally. So that's the ultimate goal, seeing a problem like this and being able to recognize that structure in the mathematics. That's Math Practice 7, recognizing the structure so that we can do this mentally, skipping a few of these steps that we wrote down. When we move on to this one, 7 2/10 times 1/9, I want you to pause and take just a second. This one's more challenging because we have a decimal now. So what if that problem were a little bit easier and it were 72 times 1/9? Well, 72 times 1/9, we could manipulate in the same way that we did over here. And so I would recognize that 72 times 1/9, if I go ahead and skip a couple of those steps, that's ultimately going to be 72 divided by 9. And 72 divided by 9, you can also calculate quickly in your head, and you know that 72 divided by 9 is equal to 8. So how does that change when it's no longer 72, but it's 7 2/10? And again, this is about looking at the structure. We can see that 72 has a decimal right here after the 2. And 7 2/10 has that decimal, it's been moved over. So it was here and now it's here. So when I go through that entire process, 7 2/10 divided by 9, so we're still going to kind of skip ahead to that 7 2/10 divided by 9. And I know it throws us off because how do we do that mentally? Well, we use that structure. We know that 72 divided by 9 is 8. So 7 2/10 divided by 9 is not 8. Here's our decimal place in the 8. If we move that over one place to take into account the fact that we moved that decimal in the beginning, now we end up with 0 and 8/10. Notice where that decimal was, and we moved it, okay? So 72, here's our decimal, 8 was our answer, here's the decimal. But if I'm moving it over, then that means we need to adjust our answer and move it over again. So we end up with 0 and 8/10. Now I want you to follow that same strategy, 1/4 times 5 6/10. Can you calculate that mentally? What would you need to do? Pause the video long enough for you to give this one a try on your own before we go over it together. Okay, we're back. Again, I want you to recognize the structure. Perhaps we don't know how to multiply 1/4 by 5 6/10, but I hope that you can see that this is very similar to the problem 1/4 multiplied by 56. And if this were the problem that I was doing, notice where the decimal place is. 56 has a decimal place there at the end after the 6. And I would recognize that 1/4 times 56 is 56 fourths, or 56 divided by 4. And that is something that I can calculate mentally. 56 divided by 4 is 14. Again, notice where that decimal place is. It's after the 4. So if I'm going to make this adjustment that the decimal place that was here at the end after the 6 has now been moved over to in between the 5 and the 6, we're moving that over one place. We're still going to go through this process and recognize that 1/4 times 5 6/10 is 5 6/10 divided by 4. And we remember that 56 divided by 4 is 14. So if I use that structure and recognize that the difference is the decimal place was here, but I move that decimal place over, I hope that you can see that we would move that decimal place over here again. Taking advantage of the structure and the different patterns that we see when we multiply, we now know that 5 6/10 divided by 4 is equal to 1 4/10. So again, as we move on through this lesson, this number talk is going to seem a little bit out of place, but it's because it's going to make connections in future lessons. We want to get this in your brain first, get you thinking about this, so when you see it again in a future lesson, you're a little bit more prepared and able to handle it. As we move on to 2.2, corresponding parts. Here is the figure. So again, if you're looking in Canvas, I will also pull up that applet, and it says each with some points labeled. And the first thing that we have to do before we do anything else is we need to label each one of these segments. If you notice, we have point P in this original figure. Can we see the point that would correspond in each of the other figures? Here's copy 1, and that would be point F. And that same point in copy 2 is called point Z. Notice that I am color coding to help us identify these points and segments a little bit easier, and we can see which parts correspond within each figure. The next one is segment LM. Here is segment LM. Where do I see that same piece of information in the other copies? We can see it's right here, only it's not called segment LM anymore, it's called segment BC. And in copy 2, it's the same segment here, but it's no longer called LM, it's called segment VW. Please continue on. I want you to pause the video long enough that you can label all of the remaining parts, figure out which pieces in one diagram correspond to which pieces in the other diagrams. So pause the video long enough to mark up your diagrams and label each one. Make sure that this table is filled out before you continue on, and hit play. Check your answers. It's okay if you use different colors than I did. It's okay if you didn't use any colors at all. But I do want you to make sure that you understand that these parts in each figure do correspond to the other parts in the other figures. Ones to mention, angle KLM. KLM corresponds to angle ABC and angle UVW. The angles can be a little bit tricky. Make sure that you're paying attention to the order of the letters. We started with K, then L, then M, so we start with A, then B, then C. Question 2 asks, is either copy a scaled copy of the original figure? Here's the original. Are either one of these a scaled copy? Thinking about what we mentioned in our last video, we talked about how a scaled copy, it's okay if it changes size, but it's not okay if it's distorted. We don't want it to be squished or stretched in any way. So looking at the original, we can see that copy 1 is just a smaller figure, and copy 2 looks like it's squished, and stretched. So it is distorted. So we can answer question 2 by saying copy 1 is a scaled copy because it's just a smaller version. Without being distorted. And this is where I'm going to switch over to the applet for you online learners. It does say use tracing paper to compare angle KLM with its corresponding angles. Let me show you what I mean by tracing paper. You can see this paper is pretty thin. If you look very closely, you can see my fingers behind it. And so we use that to place over our paper and trace on it. That way we can move things around and put it in different positions. So imagine I've got tracing paper and I'm placing it right here on the original figure. I would trace out the angle KLM. I will show you what that looks like here. So this is me tracing it onto some tracing paper. Now with some technological magic, I can take that I have traced onto my tracing paper, and I can move it around and I can see, hey, that's the same there, but it's different there. So that's how I would use the tracing paper. But I'm going to switch over to the applet so that we can see what this is going to look like in Canvas. In Canvas, you have this right here. This is kind of like me already tracing it on our tracing paper and moving it around to kind of measure the angles. So you can see if I line this up here with KLM, you can see just how big angle KLM is. And if I wanted to take that and move it over here, I can see it's the exact same angle for ABC. But if I try and move it over to UVW, I can see that it's not that same angle. It's not working out the same way. And so, with that in mind, what do you notice? What do you notice at the angles in copy 1 and copy 2? And what I noticed is in copy 1, it was the same as the original. But in copy 2, it was not the same. This is important to notice because we already came to the conclusion that copy 1 is a scaled copy. And so it's interesting to note that when it is a scaled copy, we're seeing that the angle ends up being the same. And when it's not a scaled copy, it's different. Now I want you to do the next part on your own. Now compare angle NOP with the corresponding angle in copy 1 and copy 2. Go ahead and move to the applet and explore. Pause the video long enough for you to explore using that applet. Come back ready with an answer. And we're back. I hope that you discovered the exact same thing as what we saw before, that in KLM, or excuse me, in the original, it is the same as in copy 1. But in copy 2, it's not, because copy 2 isn't a scaled copy. So that's really interesting to note. Now we're going to kind of switch gears a little bit. Our next activity here is scaled triangles. Triangle O is our original figure. And what I'm going to do is I'm going to let you pick one set. Okay, instead of me assigning it to you, you pick. Do you want to choose A and E, B and F, C and G, or D and H? You pick which one, and here's your directions. Your teacher will assign you, you're going to pick. You pick which two. And it says for your assigned triangles, you need to ask, is it a scaled copy of triangle O? Make sure you're able to explain. I'm not going to go over every one of them, but I want you to pick one. For example, if you choose A and E, you're going to look at triangle A and ask the question, is this triangle a scaled copy of O? Make sure you're able to justify why or why not, and then move on to E. Is E a scaled copy of triangle O? Again, make sure you're able to answer why or why not. If you have enough time, you can move on to each one of these other pairs. It's great to put your brain to work, but I don't want to overwhelm you because this is something that we do in class where everybody works together on it to compile that information. So pause the video and compare. Is your set of triangles that you're choosing, are they scaled copies of O? Make sure you have those answers and continue to watch the video once you're ready. I'm hoping at this point you were able to figure out which ones were scaled copies, whether you looked at all of them or just your own individual pair. Here are the ones that are scaled copies: G, E, B, and D. Now, I don't know exactly what you wrote down here, but I wanted you to explain your thinking, and hopefully you're looking at things like the angle measures. Like, it was pretty obvious that A was not a scaled copy because look at how different those angles are, right? So obviously it's not. You also can look at things like the side lengths. Like we did in our last lesson, we can kind of compare those side lengths in order to determine if it's a scaled copy. So some of them were pretty easy and pretty obvious. Others were a little bit more tricky. But here are the correct ones: G, E, B, and D. So what we're going to do with that information now is we are going to put that information into a table. Starting with triangle G, Starting with triangle G, We're going to put that on the table here, and we can see that triangle G, the side length that corresponded to 3 was 2. And the side length that corresponded to 4 in our original triangle is 8/3. And the side length that corresponded to 5 in our original triangle is 10/3. We've got those measurements on here, and so I want you to put the measurements on your own table for not just G, but all of those scaled copies. So G, E, B, and D, fill in that table with the corresponding measurements. Pause the video until that's done. And I hope that you have something that looks like this. E, we can see those corresponding side lengths are 6, 8, 10. B, the corresponding side lengths are 3, 4, 5. And D, the corresponding side lengths are 3/2, 2, and 5/2. So now it says explain or show how each copy has been scaled from the original triangle. So again, look at that original triangle and tell me, how has it changed? We'll start with triangle E. G is a little bit trickier, so we're going to start with triangle G. And I want you to see that 3 can change to a 6 by multiplying by 2. So it makes sense that all of these are going to change in the same way. 4 multiplied by 2 gives me 8. And 5 multiplied by 2 gives me 10. So when it says explain or show how each copy has been scaled from the original triangle, I'm showing that triangle E is twice as big as triangle O. We doubled it. We scaled it up by 2. So let's write that down. G is double the size of triangle O. See if you can figure out how the others are changing. The next one I'm going to talk about is triangle B. How did it change? 3 to a 3, 4 to a 4, and 5 to a 5. That one actually did change by multiplying by 1, which we know really isn't a change at all. But we can acknowledge that that same multiplicative relationship is happening, we're just multiplying by 1. So let's make note of that. B is a same size copy. And now we get to the trickier ones. What I see now, I'm going to skip ahead to D now, because D is the next easiest one. And on triangle D, how did it change? How does a 3 change to be 3/2? And I know you're probably thinking to yourself that it's half, that we're dividing it by 2, and that is absolutely correct. But I want us to get into the habit of thinking of it as a multiplication relationship. So let's write down D is half and I want you to think about what that means. That means, yes, we can divide by 2, but I also want you to understand that that's the same as multiplying by the fraction 1/2. Half of triangle O means that I'm dividing by 2, but it also means that I'm multiplying by 1/2. And finally, this one is the most challenging of all. Let's look at triangle G. In triangle G, how is it changing? Is it scaling up or is it scaling down? How does that 3 change to be a 2? How does that 4 change to be 8/3? And what we're really doing is we are multiplying by 2/3. G is 2/3 the size of triangle O. So that means what I'm doing is I am multiplying by 2/3. I'll add those same type of notes here. B is a same size copy of O. That means that we are multiplying by 1. And G is double. That means that we are multiplying by 2. That gets us into this new concept, this new idea called scale factor. So when I'm talking about scale factor, and this will come up again in just a second, but write this down. Scale factor is the number that we multiply by. To produce a scale copy. So again, that means that if you're recognizing a relationship like divide by 2, I want you to rethink, what does that mean? How can I multiply and give the same result as dividing by 2? Let's move on. On this, are you ready for more? I want you to go back to that last example. Can you choose one of the triangles that's not a scaled copy of O and describe how you could change at least one side to make a scaled copy while leaving at least one side unchanged? So again, remember, we had G, E, B, and D. A was not a scaled copy. So could you take A and explain how you can change one side and make it a scaled copy? Sometimes it will require changing two sides, and that's okay, as long as one side at least stays the same. That's your challenge question, and I'm not going to go over any more. That's just to give your brain a little something extra to do. Challenge yourself. And now we're ready for our Lesson 2 summary. I'm going to be highlighting the important pieces of information, and I think it's a good idea for you to highlight as well. A figure and its scaled copy have corresponding parts. Or in other words, that's parts that are in the same position in relation to the rest of the figure. These parts could be points, segments, or angles. So that's important to note: points, segments, or angles. And we have an example. It says Polygon 2 is a scaled copy of Polygon 1. So it says each point in Polygon 1 has a corresponding point in Polygon 2. For example, B corresponds to H. And C corresponds to I. So each point has a corresponding point in the scaled copy. But that's not all. Each segment also has a scaled copy. So we can see segment AF in our original has a corresponding segment, and that would be GL. But it's not just points and segments, it's also angles. Each angle in Polygon 1 has a corresponding angle in Polygon 2. So we have angle DEF, DEF, and that corresponds to angle JKL. So we have corresponding parts, which include points, segments, and angles. The scale factor between Polygon 1 and Polygon 2 is 2. Because all of the lengths in Polygon 2 are 2 times the corresponding lengths in Polygon 1. The angle measures in Polygon 2 are the same as in the corresponding angle measures for the first polygon. In the example, the measure of angle JKL is the same as angle DEF in the original. So angle measures are the same, and the side lengths, or the segment pieces, they change according to that scale factor. Now, that's it for our summary. Let's finish up with our lesson cooldown. We're comparing polygons ABCD and PQRS. Polygon PQRS is a scaled copy of polygon ABCD. I want you to name the angle in polygon PQRS that corresponds to angle ABC. ABC. What is the angle that corresponds in this figure? I'll highlight it for you. That would be angle PQR. Then it says name the segment in the scaled copy in PQRS that corresponds to segment AD. Here's AD in our original. Here it is in your scaled copy. That would be segment PS. And finally, what is the scale factor from polygon ABCD to polygon PQRS? Here's some hints. If you take a look at segment AB, it is 1 unit. If we take a look at the corresponding side in PQRS, we can see that PQ is not 1 anymore. Now it's 1.5. So that scale factor, how do we change that 1 into a 1.5? By multiplying? I'll write that out. How does that 1 multiply and change to a 1.5? It's because we're multiplying by 1.5. Let me write that a little bit better. 1 times some number is equal to 1.5. That number would have to be 1.5. 1 times 1.5 is 1.5. So the scale factor is 1 5/10 or 1.5. That's it for the lesson. Let's talk about homework. If you printed off that PDF, then you will see that the remaining page is your practice problems. If you did not print it off, that's okay because you're going to complete the problems in Canvas. So Unit 1, Lesson 2, Practice Problems. Here's your lesson. It's not too much, so make sure you're giving it a try. And again, I know there's challenges when you're entering your answers in Canvas. Just do the very best that you can. I'm just going for completion. After you enter your answers into Canvas, make sure that you click to see the answers. I want you to check your answers against the answers that it has in Canvas so you know if you understand it or if you need some more practice. Make sure you're sending me emails if you have any questions, and that's it for today. We'll see you next time.